Hello, welcome to another lesson, and in today's lesson we're going to do a few different things, starting with using our calculator to find sine, cosine, tangent values, and in fact the values of their inverse eventually, and then we're going to go backwards and find the angle instead of finding the ratio. After that, we're going to be solving triangles. So let's get right into it. In this first case here, we have some examples of evaluating sine, cosine, and tan functions using a calculator. So we need to ensure that our calculator is in degree mode, and then we need to use 2 decimal places. So what it means by degree mode, and degree mode, again, it's saying degree mode here. What it means by degree mode is that on our calculator, somewhere on our screen, you don't need to have this calculator, but any calculator, it should tell you that you're in degrees. This is this tiny little D symbol. So I think the way you do it is Shift Setup on the Casio, yeah. And in this menu, it says a bunch of different things, but it says degrees and radians. You have to make sure you're in degrees. That will tell the calculator that you're going to be dealing with degree symbols instead of radians. If you're in radians, for example, it'll say a little R on this calculator. That means that you're going to be, the calculator is expecting what's called a radian value, which is totally different from a degree. It's a different type of measurement for angles. So if you're in degrees, you're okay. For the first one, let's do it. Sine 36. Our answer is 0.5877. We want 2 decimal places, so it'll be 0.59. So 0.59, and then 2 decimal places is just 2 decimal places means 1, 2 after the decimal here. So notice the decimal, and then you write 2 decimal places afterwards. That's all it means by 2 decimal places. For cosine of 42, if you put that in on your calculator, you're going to get 0.74 to 2 decimal places. And tan of 62.8 is 1.95. So go ahead, pause the video, find those functions on your calculator, and see if you get the same thing as I did. One important thing to note is if you're using something like an iPhone calculator sometimes, or a basic calculator, you sometimes need to put the number in first. So you need to put 36 degrees in first, for example, and then you need to click the trig function. For example, if I pop up the Windows calculator here, if we try to do sine of 36, what we need to do first is put in 36. We got to go to trigonometry and then click sine, and it'll give us this value. Okay, that's what I mean by putting it in first. If I say sine first and then put 36 and enter, it doesn't understand. So you need to put the number in first, and that's very common for your basic calculators. So something to keep in mind. To go backwards is quite simple. By backwards, I mean we're going to use a calculator to determine the angle itself, not the ratio. Again, these answers that we're getting here are actually ratios. They can be given as fractions. This, in this case, is not going to be fractions. So the steps are to press the second function, or shift, depending on your calculator, put in the function, and enter the given value. So let me just get right to it. You can read this yourself, but let me show you how it actually works. All right. Find theta using the calculator. The important thing to know about finding theta using the calculator is that, for example, if we have cosine of an angle giving something, we need to do the inverse, okay? Cosine inverse of cosine theta is equal to the cosine inverse of 0.3527. And I'm not going to get into this too much, but the cos inverse of cosine cancels out the theta. Sorry, cancels out the cosine. Just like 1 over x times x gives 1, cos inverse of cos cancels it. So don't think about that too long. Just trust me, whenever you need to find that angle, just bring the cosine to the other side or the trig function to the other side and solve it. So in this case, the angle that we would get is 69.35 degrees. And again, I'm using 2 decimal places here because it says to use 2 decimal places. So something to keep in mind. Let me just move this over. So pause the video and try the next 2. Hopefully you've done that. Sine of the angle is 0.742, so I'm going to get the inverse. This is what I do. And then the answer is going to be 47.90. And again, these are degrees, so make sure to put the degree symbol. For tan, what did you get? Well, let's see. Tan inverse, 0.68. Let's see what that gives on a calculator. It's 34.22 degrees. All right, let's bring up the calculator again so we can see what we've got going on here. So for cosine, for example, we want the angle. In my case, I need to press Shift, cosine. It gives me cosine inverse. That's the little negative one on top. That means inverse. And then 0.3527. There we go. It is 69.3. 69.35, so 69.347. Notice there's a 4, but the next number is 5 or greater, so it rounds up to 3.5. If you're not great at your rounding, you might want to review that. Maybe type into Google how to round a number to 2 decimal places, and it will remind you how to do that. That's it for this section. Let's move on to the next page. So here's the next page. It's actually page 12. I noticed when I paused the video that the previous page, sorry, this is page 13. The previous page is actually page 12. So if you go back up here, I said it was page 11. I'm not sure why. It's actually page 12. So on this page, we are trying to get to solving these. So cosecant of 25. And the way we do this is just to understand what cosecant really is. And cosecant is 1 over sine. So all we need to do is write out this function as a sine because cosecant doesn't exist on the calculator. I'll show you that in a second. So sine of 25, you can use brackets or not. So sometimes I use brackets, sometimes I don't. So you can just write that, that's fine. And then what is 1 over the sine of 25? So you put that in your calculator, you should get 2.37. And the answer is not going to be degrees. So some students put a degree symbol there. It's not in degrees. It's not a degree. This is a ratio. We started with the degrees, and it's giving us a ratio, okay? So something to keep in mind. It's just 2.37. Now, something I said earlier was that cosine of 25 degrees is not on the calculator. We have sine, we have cosine, we have tan. We actually have sine inverse, cosine inverse, tan inverse. That's not the same as cosecant and the other ones. So we need to go 1 over. So you can just go 1 divided by sine of 25. And that'll be enough. That'll give you your answer. On some calculators, you can put a fraction, 1 divided by sine of 25, and that also will get you your answer. Where some students are feeling particularly, fancy, they'll put sine of 25, and then they'll hit this reciprocal button, which means I'm going to flip it over, put 1 over sine 25. It gives you the same thing. I recommend the first way because that's the way I'm going to write it down, but you do what's comfortable for you, okay? The second question, you should pause the video and try it yourself. It's possible that if you do that, you might notice the question's a little bit different than we're expecting because we have something on both sides this time. So it actually means we're trying to find this theta. So we're trying to find theta this time. And the way to do that is we actually need to get that secant to the other side. And the fastest way to do it is to do our reciprocal. So secant is actually 1 over cosine. So this is the same thing as saying it's 1 over 3.200. All right, if 1 over cosine theta is equal to 3.200, then we flip both sides and we get cosine theta equals 1 over 3.200. So that's just a little side note that you might want to keep in mind. All right, I'm going to erase it here, but you can watch the video as many times as you like. Actually, no, I'll keep it there. What's the harm? So the point of that was once we have this, we can say theta must be the inverse of this. Cosine inverse of 1 over 3.200. And you can put that in on your calculator, okay? So this gives theta equals to 71.79. That's our answer to 2 decimal places. So example 1 and example 2 are both kind of your special cases where you're trying to find, in the first case, you're trying to find the ratio. And in the second case, you're trying to find the theta. That's really all there is to it. So I'd like you to try 3. I'd like you to try 4. And then I'm going to write out, my goodness, I'm going to write out my answers for that, and you tell me if you get it, okay? So I recommend you to pause the video and try questions 3 and 4. I'm going to write out my solutions. If you're wondering why I can do the tan thing, remember, it's the same thing as saying I did inverse tan, and inverse tan of this. Cancel, cancel, leaving just this expression, which is what I've got here. And we see that we have our answers now. Once again, the third question here was finding the ratio. The fourth question was finding the angle. It actually said it in this case, but it doesn't always say it. Sometimes it just expects you to get it. Now, 5 is a little bit of a different beast, so I'm going to do it in two ways. There's two ways to approach this question. The first way, or I'll say first method, would be to treat it the way that we were looking at this before. So we need sine theta. Sine is not related to secant. Cosine is related to secant, but let's see what we can do. Secant is 2.504. And we can say it's over 1. Now bear with me here. The reason I do that is because secant, if we go all the way back to our rules, secant is the hypotenuse over the adjacent. That's its definition. And so if we had a triangle, for example, we would know 2.504, and we would know the adjacent side to some angle would be 1, okay? The reason I'm doing this is I'm thinking ahead, and I need sine theta, okay? And sine theta is the opposite over the hypotenuse. In this case, I don't have the opposite. I'm trying to find what the opposite is. So I'm going to say I need it y, and then I can use Pythagoras to find it. So it's the legs squared, so 1 squared plus y squared equals the hypotenuse squared. And then I'm going to solve for y. Okay, so now that I've got that, I have that it's the opposite side, okay? This is the opposite side. And the reason that's important is I can now get sine. Now I know this is quite involved. I don't actually prefer this first method. I'm just doing it so that you can see that this is one way you could do it. The third step, now that I know the opposite side, is to set up sine. Remember, the question is find sine. I know that sine is the opposite over the hypotenuse, and now based on my given information, I know the opposite and the hypotenuse. The opposite is 2.30, and the hypotenuse is 2.504. And then you would say sine of theta equals to 0.92. That's what it works out to. So quite a lot of work, and I get that. We go from secant, and then we try to use Pythagoras, and then we go ahead and use sine. There is an easier way, and I would recommend this second method because I find it's a lot easier to do and shorter. So it's easier, but it's shorter. You just need to think ahead and be clever, okay? You're trying to find sine theta. Again, let me write down that sine theta equals the opposite over the hypotenuse. One thing you can do is, because you've been given secant, remember, if secant theta is 2.504, that means that cosine, let me put it underneath actually, that means that cosine is the reciprocal of that, which means that we can find our angle. Angle is the cos inverse of this. And so the angle is going to be 66.46 degrees. Once we have that, we can go and do one last step. So the first thing is to find the angle. And then the second step is to get sine of the angle. So I'll just take sine of the angle. Our angle is 66.46. So that means it must be 0.92. That's what that evaluates out to. So long story short, sine of theta must be 0.92. Neither of these methods are like super simple. This method is just easier, okay? Choose the method that works for you. This one's quite complicated. It can be a bit tricky because, again, secant is not directly related to sine. So you need to do a little bit of mental gymnastics here to figure out, okay, how do I get to sine? Well, if I knew theta, I could get sine of theta. Or if I knew the opposite side, I could get sine in terms of ratios. So choose the method that works for you. Now we're going to move on to solving right triangles, which in my opinion is a little bit easier than this number 5 here. Okay, page 14, solve right triangles. What solve means, what it means to solve a triangle kind of sounds weird, right? Well, all it means is that we need to find all 3 sides, or all 3 angles, and we need to find all 3 sides. That's what it means to solve a triangle. Because every triangle has 3 sides and 3 angles. To solve it, means we're given 3 parts. So when we are given 3 parts of a triangle, so for example, an angle, and another angle, or an angle side, maybe 2 sides and an angle, whatever, we need to find the other pieces. Okay, so we'll only be ever given 3 pieces. So for example, we can have 3 sides, or we can have a side, an angle, and another side, or maybe we can have 2 angles and a side. Maybe we'll have 3 angles. There's multiple combinations here, but we're just going to approach it in a similar way for all of them. So the procedure is given here. You're going to sketch and label the triangle. That's absolutely crucial that you do that. You're going to state what's given and what you need to find. You're going to choose the correct trig ratio at some point along the way. And then you're going to check a few things, that the largest side is opposite the largest angle. So for example, 90. Smallest side is opposite the smallest angle. Sum of the angles is 180. This stuff can be a little bit confusing to think about this, so maybe don't worry about it for now, but we will use it. And to solve the right triangle, absolutely crucial. These are our 3 steps. Pythagorean theorem. So the concept that your 2 legs squared and added together are equal to the hypotenuse, using trig ratios, sine, cosine, and tan. And then your angle sum principle, the idea that if you add all your angles together, that will equal 180. And that becomes extremely important when we're solving triangles. Let's jump into an example and see if we can make sense of this process. So this question says we need to solve triangle ABC. And we're given that B is 5, A is 2, and angle B is 90. We need to use 1 decimal place in our answers whenever necessary. So I'm going to go ahead and draw a triangle first. I'm going to draw a regular triangle in our first quadrant. Let me see if I can make it a little straighter. Not going to happen. I'm just going to do it the old-fashioned way, just like you would. So quadrant 1 would look like this. This is my, oh my goodness. This is my right angle here. Our right angle is B, so I'm going to write that on it. And then A and B, or A and C, where you draw those is kind of irrelevant. It doesn't matter where you put it. You can put A on bottom, you can put C on top. For the purposes of this question, I'm just going to go A, B, and C, just like this. And to keep track of everything, I'm going to put angles in a small little table here, and I'm going to put sides here. Remember, earlier in this page, I did say that you should state what's given and what you need to find. So you can only ever have angles A, B, and C, and you can only ever have sides, little a, little b, and little c. Let's figure out what we're given. Well, we're given b equals 5, little b I should say. That's across from big B. We have a equals 2. It's across from big A. And then we are given the angle of B, which is 90. So in this case, we're given 2 sides and an angle. So this is actually what we would call a side, angle, side example. That might not be super helpful, but if you do know you have a side, angle, side, you're actually going to follow this method every time. So the first thing we're going to do is solve for this missing side, because if we have 2 sides given, we can definitely solve for the 3rd side that's missing. So we're going to use Pythagorean theorem. And to do that, remember that if it's in like leg form, we can say leg squared plus another leg squared equals the hypotenuse. Well, in this case, let's just say that c squared, that's one of the legs, right, c, plus a squared equals our b squared. Or if we rearrange that, our c squared equals b squared minus a squared. So take a moment to make sense of that. It's crucial that you can understand that piece. I'm just going to zoom out a tiny bit so I have all the space. All right, let's fill things in. I know I'm going to solve for c, so I'm putting the square root around it. b squared is 5 squared. Then we have 2 squared. Square root it. C is then the root of 21, or in other words, C is equal to 4.6. So I'm one step closer to solving this thing. I'm going to make it blue, just so we can color code a little bit as we go. And this is now an angle, no, sorry, it's a side, 4.6. All right, I've got my side 4.6. I'm going to write it in on the triangle. You don't need to, but I like to keep track. Now, I have all of my sides. Now I need to work for the angle. To get angles, when you have sides given, let's use trig. Trigonometry. I'm going to use trig to find the angle. I'm going to choose the angle A. You could have chosen to find the angle C. It doesn't matter. The point is, if I've got all these sides and I've got a right angle, I can easily find an angle inside. Okay, so let me just, because I'm talking about A here, I'm going to draw the angle here. I know that the opposite relative to that is down this way, so this is my opposite. I know my adjacent is next to it, so that'll be my adjacent side. And I know my hypotenuse is always opposite the right angle. So this is my hypotenuse. And let's set up sine. Sine's a nice, easy one to work with. Sine of the angle is equal to the opposite over the hypotenuse. You should remember that. SOHCAHTOA. Remember? SOHCAHTOA. Opposite over the hypotenuse. I have the opposite. I have the hypotenuse. That means I can find that angle. So sine of angle A is the opposite over the hypotenuse. And we know how to solve this now. We just finished working on this. Get the inverse. Sine inverse of 2.0 over 5.0. Calculate that on your calculator. You'll get that A is equal to 23.6 degrees. And once again, I'm going to color code this. That is our angle A is 23.6. I'm not going to add it to my diagram because it would muddy it up, but I'll write it here just so you see. It would go there. Okay, that's where it would go. Now our third step, what are we missing? Well, let's take a look at this. We have all of our sides, all good over here. We have two of our angles. What property have we not used yet? Well, we go up the page and we say, we've used Pythagoras, we've used a trig ratio. We should be able to use the angle sum principle next. So the angle sum principle means we add all the angles up, they'll get 180. So I'm just going to use the angle sum principle. So there we go, that's the angle sum principle. We know A, we know B, and we're just looking for C. Okay, just rearrange this. You bring them to the other side, no problem at all. C must be equal to 180. I'll just show it this one time. 23.6 degrees minus 90 degrees. We get that C must be equal to 66.4 degrees. And there we go. Color code it. Now we've got our full things. We've got three angles, we've got three sides. We have officially solved this triangle. Now, one note, there are multiple ways to solve this problem. Absolutely, I think that this step is pretty much, there's no choice, okay, there's no choice. But in the second step, you could, instead of trying to find A, remember I'm putting down you could have found C. There's no reason why you couldn't have found C. Just set that as your angle, and then do, opposite would be this side, adjacent would be this side, and work it out that way, and figure out what you have. In that case, you would have had the adjacent and the hypotenuse, and you would have been able to use cosine instead of sine. So there are multiple ways to solve these problems. Don't get too overwhelmed. Just take it step by step. When you have a bunch of sides, try to use Pythagoras. If you have sides, two sides, and you're looking for an angle, try a trig function. You're going to fail a few times before you get it right. It's just a fact. It's just the way this stuff works. But the more practice you get, the better you'll get at this, okay? One last thing is, if we were to have gotten C and worked it out here, we would have gotten C. Our missing angle, our missing angle in the third step would have been A, right? We would have had C, we would have had B, we would be finding A, and it would have worked exactly the same way. I'm not going to show you the solution to that, but if you want to try it yourself, you can go ahead. Let's move on to the next question, question 2. It says solve triangle DEF given that F is 9, angle E is 90, and angle F is 36. So I'm going to draw my triangle. I know it's right angle. Why does it keep doing that? It's so strange. Draw my right angle. I know that the right angle is my E. I know across from E must be little e. It looks like I'm looking for that. And then I can draw my triangle any way I like. Let's just put here F and here D. It really doesn't matter. It's totally up to you. I don't have small d here, so I'll just leave that blank. In fact, I'm not going to put the question marks on the diagram because it's just going to muddy it up. But little f we do have. It's 9. So once again, let's write down our possible angles. D, E, F, and then our possible sides. That's little d, little e, little f. What am I given? I was given small f, so that's a side. Angle E, that's our 90. And then angle F, 36. So we've got a little bit of a different situation. We've got 2 angles on a side this time. So this is really angle, angle, side. The previous example was side, angle, side. This one is an angle, angle, side triangle. For angle, angle, side triangles, when you have 2 angles, it makes the most sense to solve for that third angle first. So I'm going to calculate the missing angle, D. Remember, I've got 2 angles that I know. I'm going to find the missing angle. And just use the angle sum theorem. It's actually the angle sum principle, but same. No big difference, really. So that means D plus 90 plus 36 is 180. So I'll just take them all away from 180 degrees. Okay, I should be using the degree symbols here. And in the previous question, okay, I have the degree symbols on those. What you'll find, if you take them all away from 180, what you're left with is 54 degrees. Okay, we got 54 degrees. I'm going to write that in here. We've got 54 degrees. Probably don't need to color code it, but it doesn't hurt. 54 degrees. What am I going to do next? Well, the second step in many cases is to use trig. So I'm going to use a trig function to get D. Little one, little lowercase d. Okay, and you might be wondering, why am I choosing to find D? Well, let's just look back at my triangle. There's actually a piece of information I didn't write on the triangle that I should have, and that's that I know the angle for F. Okay, I know this angle F. I also know the opposite side to F. So what I should say is that this is the opposite side. Relative to this angle F that I know, that's my opposite. I know that this D side is the adjacent, and I know that, of course, E is the hypotenuse, no matter what angle I'm talking about. And so I'm thinking, I have an angle, I have a side, I can easily solve for the E side or D. So with these 2 things, I can get the hypotenuse, or with those 2 things, I can get the adjacent side. So I'm just choosing to get the adjacent side, and I'm going to use Pythagoras later to solve the missing side. All right, so just follow me here. We know that tan theta equals the opposite over the adjacent. Let me just be clear here. In this case, I know the theta, that would be 36. I know the opposite, that would be 9. And I'm looking for the adjacent, so I can solve for that. So if I only have one unknown, I can solve. Maybe from another point of view, you would think, well, what if I wanted to use cosine? Or what if I wanted to use sine? Well, let's take a look at what sine would give us. SOHCAHTOA. What about sine? Okay, do I know the angle? Yes, I know the angle F. Do I know the opposite? Yes, I do. That would give me 9. That's the angle, the side F. I could also solve for the hypotenuse. So I could choose sine here. Or let's go one step further. and say, what if I was thinking about cosine? Cosine is the adjacent over the hypotenuse. Could I do this? Well, the angle you definitely have, the adjacent side you don't have, and the hypotenuse you also don't have, okay? So that's a big no. We definitely cannot use cosine, but we could choose to use sine or tan, all right? I'm just going to choose tan because it's a little easier when I move forward and do Pythagoras later, but there's no better choice. It's either tan or sine. I'm just deciding to use tan. So I could have chosen to solve for E. All right, let's put tan. Tan of some angle is the opposite over the adjacent. In our case, this means that tan of the angle F is the opposite side, 9. Sorry, opposite side F over the adjacent side, D. So I'm just leaving them all blank. Sorry, I'm leaving them all as their letters so you can see how they make the connections. Now let's fill it in. Tan of the angle being 36, is equal to the side F, 9, over D. Now we've got a bit of a pickle because we need to solve for D. Well, if you remember from the previous unit, that's an easy operation. We can cross multiply, or we can think of it as being switched with the term to the left. All right? And what happens now, let me just draw this little curtain so I can start again at the top. If I switch places, D is equal to 9 over tan of 36. So notice that they switched positions. I literally took what I saw on the left and what I saw on the bottom and I switched them. And that's okay, you can always do that in this situation. If you calculate that out, just put that expression here, put this expression on your calculator, you will get 12.4. And so D, side D, is 12.4. Sorry for those dingings. Maybe I'm popular. Maybe I got an email, who knows? Maybe it's one of you. Let me try to color code this. You can probably go ahead and see what I'm going to do. In fact, it's probably pretty obvious. I haven't used Pythagoras yet, so I'm going to. But that's the answer. That's 12.4 is D. All I'm missing is E. And in order to get the third side, I pretty much always use Pythagoras. So for the third side, sorry for all the zooming. I'm just trying to get a good look at the page here. For the third side, I'm going to calculate E using Pythagoras. So use Pythagoras to find side E. And if I had already solved for side E here, I would be now solving for D. But I'm not going to do it every single possible way. This is just one way. So just watch me do this. 2 legs. This is general Pythagoras. So instead of confusing with that, let's just write it as I see it here. This is for our situation. That means that E, well, if we calculate it, it gives 4 squared plus 9 squared. This gives us 15.3. And I've officially solved the question. I've solved the triangle. I've got every side. Now, I want to point out one other thing. Notice that even though I did my regular 3 steps, I did my angle sum, I did my trig, I did my Pythagoras, you could have chosen step 3 to be trig again. All right? There are multiple ways to solve these triangles. Let me just, to the side here, show you how I would have done that. There's an alternate way to have done part 3. So on the side, an alternate way. I'm going to say use trig to find E. Instead of doing Pythagoras, we can skip it all together. Just watch my workings and see if it makes sense. Okay, the exact same thing. This is what I was talking about when I talked about step 2. If you go back and watch the video where I said we could have used sine, well, of course we could have used sine, and if we used sine, we would have been able to get E in a different way. So there are multiple ways to tackle these problems. They'll all seem confusing until you get the practice, so I'm trying to give you a method to solve them. But know that if you have an angle side triangle now, you can follow this exact process, and you should be able to get the answer. Let's try to get question 3 done. So question 3, as we're going to see very quickly, is almost identical to question 2, but I want to do it just because there is a slight difference in the way that we approach solving the angles. So first of all, let's write down all of our possible angles, and we're going to write down all of our possible sides. So T is 65, A is 90 because it's in a right angle, and this is our L, 32. Okay, so that's what we have so far. Just to be clear, I could probably label my sides that I don't know as little a and little t, but this is basically all I have, but it's enough because I can see I have an angle, and a side. So I've been calling that angle, side. So I have an AAS triangle, which means I can follow the same rules as the previous question to solve it. Now I'm already given an angle, so I'm going to go ahead right now and label this. That's my angle, so across from the angle is going to be my opposite if I need this, which I will. This will be my adjacent side, and the hypotenuse is of course always across from the right angle. So if I need that, I got it. But first I'm not going to need it. The first step, I'm going to calculate my missing angle. So I'm going to calculate the angle L using my angle sum principle. So this is simple enough. You can watch me do this or do it yourself. Okay, and we see that L is going to be 25 degrees. So I'm just going to write that in there, 25 degrees. My next steps, all I have to find now are sides. The problem is I don't have two sides. So if I don't have two sides, I can't use Pythagoras. I must use trig. So I'm going to say, I'm going to use trig, or use trigonometry relationships to find either A or T. In fact, I can do it either. I'm just going to find A because it's the first one I saw here. All right. Now let's set up our trig functions and see if we can choose which one's going to be appropriate. So we know that so, ka, toa. So katoa. Let's go through step by step and see what I could use. Sine of the angle. So I have the angle. Do I have the opposite? No. Do I have the hypotenuse? No, I don't. So sine is not going to work for us. Cosine. Do I have the angle? Yes, I do. It's right here, 65. Do I have an adjacent side? Yes, I do. It's 32. And do I have a hypotenuse? No, I don't, but that's okay because it's just the one unknown. So I'm just going to go ahead right now and get cosine. All right, I'm going to get cosine of the angle. So cosine of the angle T is equal to, well, let me just write it down to show you less steps. Cosine of our angle being 65, is equal to the opposite, T, sorry, not the opposite, it's the adjacent, which is L, or 32, over the hypotenuse, which is A. And you'll notice I only have one unknown here. That's fine. I'm going to do the exact same thing as I did before. I'm going to switch their places. And we'll get A very easily. A is equal to 32 divided by cosine of 65 degrees. And you put that in your calculator very carefully, putting brackets where you need them. 75.7. And is this an angle? No, it's not. It's a side, so I don't need a degree symbol. I'm going to go ahead and write that in, 75.7. Now, on your calculator, you might want to know how to put in this answer here. So it's quite simple, 32, you don't need to put 0.0, but you can if you want, divided by cosine of 65. And it's important that you close the bracket. If almost every calculator, when you click a sine function or a cosine function, tan function, they'll give you a bracket. Close the bracket. That makes sure that you don't mess it up. The reason that is cosine is not anything in itself. It always takes a number. So let me finish this, 75.7. Okay, gotcha. What I wanted to say was if you click cosine, it's like, well, give me a function. Give me something to put into this, because otherwise it's nothing. You know, it even forces it to take its last answer if I didn't give it anything. So something to think about. Cosine has to be of an angle. It doesn't actually mean anything on its own. For our third step, to save time, I'm going to use trig again. And I'm going to use that trig to find the angle, to find side T. And the way I'm going to do that is this sucker right here. Do I have the angle? Yes, I do. Do I have the opposite side? No, I don't. But do I have the adjacent side? Yes, I do. It's L. And the reason that I'm choosing this, I'll come back to after. The reason why I'm deciding to use trig and not Pythagoras. Very important step, but let me show you this. So tan of the angle being 65, is equal to the opposite, which is t, divided by the adjacent, which is 32. And now in order to get this, I do a cross multiply, okay? All you need to do, just multiply by 32 on this side to get rid of the 32. And just add the 32 to this side. Cancel, cancel, and then we get our answer, okay? So in other words, t is 32 times tan of 65, or t is equal to 68.6. Our triangle is now solved. We've gotten 3 answers out of this, and we've got it. So the reason that I don't use Pythagoras here, or I chose not to, is look, if I used Pythagoras, I would end up saying that, well, first of all, a squared plus b squared equals c squared. So let's put in our legs. At the time, before I did part C here, at the time I knew 2 legs. I knew L, so that, and I knew, actually I didn't know an L, the other leg. The other leg was T, which is what I'm looking for, and that would be equal to C squared, or A, which I indeed did have in this case, 75.7. So 75.7 I had, I would square that. L was 32, okay, let's square that. My point is, and I'm trying not to get too muddy here, I could solve for t, that's not a problem. But look, this L was given to me, let me make it more clear. This L was given in the question. This A I solved for. And if I use that A to solve in the second step, I'm in danger of using a number that maybe was wrong. What if I calculated this wrong? Then it would give me this wrong, and it would mean that my t that I calculated out of it was wrong. So try not to use things that you've calculated in your future question, if you can avoid it. Like if you can not use something you've calculated later in your question, that's very safe. Because as soon as you make a mistake partway through the question, if you use it again later, you are in risk of messing up your future answers, okay? So once again, if we look back, I'm not sure what I did there, selected something by accident. If you look back, angle, angle, side, I was able to calculate it, angle, use trig, and then use trig again, which actually the alternate method is probably the preferred method. And then C, same idea. Calculated the angle, use trig to find A, and then use trig to find T. So that's how these questions are done. For this question, I'm actually not going to explain it. I'm just going to write it out for you. I'd like you to pause the video and try it yourself. I'm actually going to start by listing my angles and sides, and then we can compare all of our information after. This is not a new type of problem. It's the exact same. So these are the answers you should get when you solve this question yourself. I will write all the workings down, but I'm just not going to talk through them because I've actually said everything I need to say about this. All the basics are the same. So those are the answers you should check against. The things you're actually solving for are going to be these numbers. And then, pause the video, try it yourself, and then you can look and see how I do it now. Okay, and what you can see here is I follow the exact same method once again. Sorry, there's a siren going by. And for the last step, I'll say we could use Pythagoras here. And the reason for that is by the time I get to the step 3, I know D, and I would know S, so I could find the third side. The problem is I would be using a calculated value to then solve for the third value, and that's never safe. So I'm just going to say it's not safe. All right, the rest of the practice is for you to do. I will put the answers here and, work through it, see if you can get it. These are my answers for question 1. For question 2, these are the answers that you should get. You can pause it here. And for question B, These are the answers that you should get for this one. You'll notice that this one is actually side, angle, side. I'm given two sides at an angle. And finally, for C, which I believe is the last one, we get this here. So we notice that we were given two angles and a side. So this would be, once again, angle, angle, side. So what you'll notice is that for all of these, the n here was 90 degrees. So that was given at the very top. Another thing I want you to notice is that the answers to the practice were given here. So if you want them all in one place, you've got them. The next class, we're going to be dealing with solving word problems. And depending on how things go with this, maybe we'll have an extra class on it. You must absolutely let me know if you need my help. I'm happy to have office hours for you. That's it for today's lesson. Have a great day.